exploration missions, and even, as Jim mentioned, to forecast the weather. We've worked with a variety of partners, Science Mission Directorate, Human Exploration and Operations Mission Directorate, several of the NASA field centers, even the Spanish National Research Council on these technologies. And there are 4 particular items that I'd like to highlight for you today. 2 of these will be utilized during the entry, descent, and landing phase of the mission, those 7 minutes of terror when the spacecraft first enters the atmosphere and then is descending all the way to the surface. And then the other 2 technologies will be utilized when we reach the surface during the surface operations of the rover. The first of the technologies I want to highlight is called MEDLEY 2. That stands for Mars Entry, Descent, and Landing Instrumentation, and it's the second round for this. We have an image that I'd like to show that shows the spacecraft. You can see there the heat shield on the bottom and the back, what they call the back shell, on the top. And embedded in the heat shield and the back shell are a number of instruments. There's thermocouples, there's heat flux sensors, and there's pressure transducers, and they collect data at the various locations on the heat shield during the descent and the back shell during the descent through the atmosphere on those last 7 minutes of flight. When we take measurements of this nature, we answer a lot of questions, and when we look at the data, we realize that we have new questions. And so MEDLEY 2 builds on the heritage of the 2012 landing of Curiosity, where we had similar types of instrumentation, not in all the same locations on that flight, and we learned a lot, and we raised some new questions, and some of those questions we're going to answer on this flight. The way we use the data is to validate models that we use when we develop new spacecraft that we want to land on Mars. Jim showed the progression of rovers from small little rovers to things like Perseverance that's the size maybe of a small SUV. Well, for human exploration, we're going to have to land something the size of a 2-story condominium on Mars, something that weighs 20 tons or more, not just a ton. And so, I mean, it's amazing to be able to land a ton on Mars, but eventually we're going to have to land 20 tons on Mars. And so as we design the new landing systems and the new spacecraft that we have on Mars, it's important to be able to model that landing portion of the mission and make sure that we can land those systems safely. So the data we get from MEDLEY 2 will be able to provide that validation for entry, descent, and landing models. Another technology that I want to highlight is called terrain relative navigation. It allows us to pinpoint the landing zone on Mars, and this is a technology that will allow us to land more accurately in the locations we want and in more hazardous locations. You know, in Apollo 11, Neil Armstrong looked out the window and said, "I don't really like where